So before we can actually get into the actual stoichiometric calculations, we need to learn how to do what's called balancing an equation. If you think back to the idea that matter is not created or destroyed in a chemical reaction, that means that whatever stuff we put into the reaction, we better get that much stuff out of it. So if I put the following reaction up, this is where we started the chapter. Sodium hydroxide plus HCl gives us water plus sodium chloride. Is this equation balanced? Well, let's see. We started with one sodium atom. We ended with one sodium. We started with one oxygen. We ended with an oxygen. We started with actually two hydrogens. Ended with two hydrogens. And we started with a chlorine. And we ended with a chlorine. So you can see we have the exact same number of atoms on both sides of our reaction. So that means our equation is balanced. But not every equation starts that way. But what about the other reaction we started with? H2 plus O2 reacts to form water. Is that balanced? Well, again, we need to look at what's there and on each side. So on the left side, we have two hydrogens, and we have two hydrogens on the right. But on the left, we have two oxygens and only one on the right. So now we need to fix that. How do we do that? Well, that's when we start to add what we call our stoichiometric coefficients. So if I put 2 here in front of water, now I have two oxygens on the right and two oxygens on the left. So oxygen's balanced. Now, unfortunately, as a consequence of balancing oxygen, I now have 4 hydrogens on the right and only 2 on the left. So I need a 2 out in front of hydrogen. But now this equation is balanced because I've got 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, 2 oxygens on the right. So let's do a couple more of these. And if we're going to give you a method that if you've never done these, that will hopefully make it a little bit easier. Now, the first thing is some atoms are easier to balance than others. And we're going to always avoid the most difficult ones until we get to the end. So what are we going to avoid here? We're going to avoid oxygen. Why am I going to avoid it? Well, if we look at our reaction, oxygen appears in multiple places. So if we need to start adding oxygens, we may not know, do we add them to carbon dioxide or do we add them to water? So we'll save that for the end. But what I'm going to do is just make a list of the different atoms we have here, carbon, hydrogen, and oxygen, and I'm just going to list how many of each one we have. So one carbon, one carbon. Left side has 4 hydrogens, the right side has 2 hydrogens. Left side has 2 oxygens, the right side has 3. So how are we going to balance this? Well, the first thing I'm going to do, we've got 4 hydrogens on the left, 2 on the right. So if I put a 2 in front of water, now my hydrogens are balanced. Now that balanced hydrogen, but it does change oxygen. So our oxygen went from 3 to 4. So now I need to add oxygens on the left. I have to deal with oxygen now because everything else is balanced. But if I change O2 here and make them 2, now I have 4 oxygens on the left and 4 oxygens on the right. That means everything is balanced. And we've successfully balanced this equation. All right, let's do another one. Potassium plus O2 gives us K2O. So to start, we have 1 potassium, 2 oxygens, 2 potassiums, 1 oxygen. So I'm going to start by putting a 2 in front of potassium. That means potassium is balanced. All right, now what do I need to do to balance oxygen? Couple different ways I can go here. But probably the easiest way is if I could put 1/2 here in front of oxygen, then that becomes balanced because I only have 1 oxygen on the left. Can I do that? The answer to that all depends on how you think of the chemical reaction. So if you're thinking of this reaction as 2 atoms of potassium react with half an atom of O2, that doesn't work because can we have half of an atom of something or half of a molecule of something? We can't. But if we think about this in terms of moles, can you have half of a mole? Certainly. So this would be 2 moles of potassium react with half a mole of oxygen to form a mole of potassium oxide. Now, some people don't like fractions in their chemical reactions, and that's completely understandable. Is there a way around it? Yes. We can just double the entire thing. 4 potassium plus 1 O2 gives us 2 potassium oxide. And I would consider either of these to be balanced. All right, what about something maybe a little bit more complicated? So we're going to start with aluminum nitrate and sodium hydroxide, and these will react. To form aluminum hydroxide and sodium nitrate. So I'm going to do everything I can here to avoid oxygen. Why? Because oxygen shows up in every single compound here. So we're going to save it for the end and see if we can get away with that. But we actually have 5 different atoms to balance. So we start on the left with 1 aluminum, 3 nitrogens, 10 oxygens because we have 1 oxygen in sodium hydroxide. The nitrate has 3, but there's 3 of them, so 3 times 3 is 9, plus the 1 gives us 10. 1 sodium, 1 hydrogen. On the right side, we have 1 aluminum, 6 oxygens, 3 from the 3 hydroxides and 3 from the nitrate, 1 nitrogen, 1 sodium, and 3 hydrogens. So where do we start? Well, you can start anywhere you'd like, as long as it's not with oxygen. Oxygen is going to be your hardest element here to balance. So I'm going to start with nitrogen. 3 on the left, 1 on the right. So I need to put a 3 here in front of sodium nitrate. So I now have 3 nitrogens. Unfortunately, sodium was balanced. It's not anymore. And now I have 12 oxygens. All right, so, and this happens sometimes, especially in more complicated situations. We balance one element and something else becomes unbalanced. So should we fix sodium? Well, if we fix sodium by putting a 3 here in front of sodium hydroxide, now sodium becomes 3, hydrogen becomes 3, and oxygen becomes 12. So oxygen, which was our most complicated element to balance, turns out ended up being the easiest one to balance because we did all the others and it just kind of took care of itself. And that will happen in many cases. So as we transition over into doing actual stoichiometry for some chemical reactions, um, this always needs to be your first step. Look at the reaction, determine if it's balanced. If it's not, go through and balance it, and then begin your calculations.